Delaware is a really interesting case. The river basically runs down a fault line, and you've got the Delaware and the New Jersey side. I'm just trying to think, the Delaware side is rocky and the New Jersey side is not so rocky. And it's very, very difficult, if not, it's basically impossible using current techniques to be able to pick up such a stark vertical discontinuity. Before we got there, they'd done 134 boreholes within a 6 kilometre range to try and define that vertical discontinuity. We found it for them in less than a day and created, again, a digital twin of that river so that they could then go and dredge it. Look, when you start innovating, you kind of get bored. Anyway, we had another job for them. They were they had a contract dispute because out at Wilmington, there's when you get fresh water coming into salt water, you get flocculation of the muds, and you get a build-up of like a fluffy mud. And once you get a certain build-up or an accumulation of fluffy mud, at a certain level you start to get a high viscosity layer, where if the ship hits a high viscosity layer, it loses navigability, it starts to run into things. So you can punch through mud up to a certain point, and there's a lot of conjecture around the world what that point is, but basically it's called the nautical depth. And if you're dredging fluffy mud above the nautical depth, you're wasting time because the ship's just going to push through it. But if you don't get to the nautical depth, you run into huge risks of the ship losing steering and crashing into things. So we kind of got bored and figured out a way. I mean, it's sort of intuitive if you think about it, but you can get the resistivity to give you that nautical depth. And we figured out a way of doing it, and we went in with the US Army Corps and resolved their dispute by figuring out the difference between traditional perception of where the bottom needed to be and the actual nautical depth. So that was kind of a cool job, and it ended up saving the US Army Corps a bucket load of money in unnecessary dredging. Yeah, cost benefits, risks, all that sort of stuff. I'll just show, because I like Steve Jobs, I'll just show one more thing. We're 100% digital, so here's Metro in virtual reality. Doesn't do anything. If you had glasses, it would, but I don't have 100 pairs of glasses. But imagine, with your client, a lot of it's kind of fluffy stuff, but there are some real engineering applications to putting out data into augmented and virtual reality.
So that's the Sydney Tunnel.
That's the Sydney Tunnel underneath the Sydney Harbour. And the changing of geology. There's a paleo channel there that everyone else missed, which is kind of fun. They didn't believe us at first, but now they do. Well, I'm done. Yep.
Questions?
Sorry.
I'm just intrigued in what technology you're using to measure the resistivity. How do you know you're not measuring the low resistivity of the salt water?
Ooh, man, it's thought about it. Well done. So most people, when they're doing geophysics, sit their cables mid-water or on the surface. If you want any resolution, you have to be on the seabed. And because of that, we run a string of CTD meters up the cable, and then we we have processing algorithms that incorporate CTD or conductivity changes associated with the seawater into our processing. So we basically remove the residual that's lost to the seawater and then calculate what's gone into the seabed. There's a few other things you need to do, like account for the Earth's magnetic, because you're dragging a big long copper cable through the Earth's magnetic field, so you need to factor that out as well. There's a few other tricky things that we try to do, but that conductivity is a great one. And often you get, particularly in riverine environments, you get salt wedges, and where people aren't taking into account those salt wedges, you get differential losses to the seawater. If you're doing it properly, you need to account for all of those. Sorry.
So are you able to sort of work out what type of rock it is, or at least densities, things like that, so you can then feed that information to whoever's going to do the borehole, so they can choose a appropriate way of doing it? So
the great myth of geophysics is that there's one technique in particular I'm thinking of, seismic refraction. There's, for some reason, the propagation of a myth that the seismic velocity equates to a certain rock type. It's rubbish. Every single site has different geophysical properties, be it for velocities or electrical resistivity. So the short answer is we can look around at the geology and make educated guesses about what it's going to be, but you have to just work on the premise that this blob is different to this blob, and then go and test it. And we'll work with geotechnical engineers to make an educated guess about what they're going to hit, and then design an appropriate testing technique with the client based on a reality rather than whatever's cheapest at the time. There's a lot of different ways to do it. I guess what you're alluding to is there's a lot of different ways to drill boreholes, and some of them are very cheap and very inappropriate.
Does this technology have application beyond the marine environment?
Yeah. Look, we have a full land suite as well that does a similar thing, but for the purposes of an exercise that looks far cooler, the water stuff.
Did you have to design and create your own sensor arrays and things like that, or do you use off-the-shelf equipment but have the smarts and the interpretation of the data coming from them?
Look, geophysics, and there's a number of reasons for this, that from both consultancies and owner side, geophysics has been left to wallow in the 60s and 50s. So most of what's on the market at the moment, frankly, is rubbish. So yes, we've rebuilt everything from the mathematics to the acquisition arrays, to the way the data is handled in the triggering environment, and then sent to the storage environment, and then all of the processing algorithms are ours. Often we get clients saying, "Oh, we want your raw data." Our cable geometries aren't like anything on the market. We don't give out our cable geometries, that's our IP, so you can't process our data with anything else on the market. So everything is hand-built. One of those cables is like 8,000 euros worth kind of thing, and hand-built. Like it's lots of, I mean, you can imagine if you're dragging a cable along the seabed, along rocks and corals and stuff like that, you're going to have a serious bit of Kevlar in there to try and armour it. So yeah, they're really expensive. And it was a lot of trial and error to get it working. Yep.
How did you get started in developing all your own stuff? Were you in this industry doing geological surveys with existing equipment or something, and you thought there had to be a better way, or what actually got you started in this originally?
Look, a friend of mine has the raw concept. My business partner has the raw IP. And then I actually, you know, in my deep dark past, was working for GHD at one stage, and I worked with I employed this guy on a job and then quit GHD, and you know, look, originally this tech was designed because, you know, there's nothing approaching the resolution and the quality of what we can deliver in the market in the world. So yes, we originally built it because, you know, it needed to be built. And then my focus is being an environmental scientist once upon a time, and being interested in sustainability, and also having, you know, as much as I tease GHD, having a background in GHD led me to realise the importance of this technology in terms of how it can assist consultants to make, and owners to make educated decisions.
I
just have a question about how you manage scalability of these types of technologies as the word gets out there and more people want to see it work for them.
Yeah, look, I mean, obviously we can build as many as we need to. They're not, you know, when I say we build everything, you know, we use OEM parts. So, you know, we can go to the, you know, not JCar or anything, but, you know, the industrial shop to buy the bits to put it together. And we're continually keeping up. Like you know, moving from Windows XP to Windows 10 was a major hassle and required a complete rewrite of everything. So, you know, but we are keeping up with the trends in the technology. So, you know, scalability, everything we have is currently current. It's based on, you know, the processing is based on the Windows 10 core, and the hardware is based on modern hardware. So we can buy everything, we can build as much as we need to. But the reality is it's hard work towing something on the seabed. We can do it really quick, but not many people actually want to do that. You know, you go to partners and you say, oh yeah, but you have to do this, and they're like, get money. But, you know, so, you know, but again, we're really quick. I mean, Geelong Harbour, we did it in 9 days. 550 kilometres of line data. Yep.
Have you looked at employing autonomous vehicles to the?
Yeah, funny you say that. We have, and we do a bit of work for De Beers, and De Beers have assets or you know, concessions that are in quite deep water. So we do have a chalkboard design of something to fit in a deep sea AUV. But again, you know, one of the issues is you know, if you're only looking really shallow, you can do a really short tail. But you know, one of the issues is that you are towing something off the bottom of a $1 million AUV. You know, you need to know a whole lot about the bottom before you consider that, and the R&D around it will be probably another $1 million. So yes, we have considered it. Yes, it is possible, particularly with the batteries technology we've got now. So it's just a matter of time and market need. Sorry.
I guess many of us grew up in an environment where we learned that risk should be allocated to the organisation that can best manage it.
Yes.
Although most of the client organisations and government organisations would tend to resist that, certainly for recently. I guess we're seeing that there are risk mitigation phases or risk mitigation activities being, you know, inserted into the front end of projects or project definition studies now, and certainly some of the things I've been involved in. Are you seeing the same sort of change in attitude creeping into the genetic world, or is there still a long way to go?
I think, look, it's hard to say. I mean, it's kind of like nuclear fusion. It's always a little bit ahead. You know, I've got letters from consultancies and organisations telling me how crap I am and how I don't add value. And yeah, and it's very difficult to reconcile that with the evidence. We've never had any of our data rejected from a job. We've never had any data disproved. So look, there's a lot of money tied up in boreholes, and a lot of people very interested in doing a lot of boreholes. But the reality is you can do, I mean, a borehole is 75 millimetres in diameter, and the only way to do enough of them to mitigate risk, and you saw that one example of those big vertical sections, the only way to do enough boreholes to mitigate risk is to get out your excavator and dig up the whole site. So there's pushback from that, because the reality is we might reduce the requirement for boreholes down to 1% of what would otherwise be needed. You know, you look at the South Pacific, you know, we can do a whole island in the time it takes someone to do the geophysics for one tiny corridor. And not only can we do the whole island in that time, but we can also then go and target enough boreholes to prove our data, because we process overnight if we need to. We can do enough boreholes to prove our data before we actually leave site. And then we can give that data to the island as an asset, an enduring asset, so that, you know, once they've built that jetty, if that falls down, they can build another one without any more reshoots. Look, I think it's coming. All of a sudden, you know, senior people in infrastructure are answering my phone. I teased politicians earlier today, earlier in my speech, but the reality is that politicians, in my experience, the right politician is the most suitable person to advocate for innovation. And I had a politician organise a meeting on a senior level in New South Wales recently, and he actually came into the meeting and he said, I'm not going to say the name, you know, Mr. X. I'm sitting in this meeting because the Premier, the Deputy Premier, the Roads Minister and myself believe in this tech, and we're sick of these meetings going nowhere. There's not many people that can pull people to account like that. So, you know, as much as I tease politicians about banding around innovation, it is really hurtful that when they do it disingenuously, because they cheapen the word, yet they're most, you know, empowered to actually help people like myself and other people around who are SMEs that really need that help. And so we're getting that support now, and hopefully we're close.
So can you just outline, I think I understand, but what are the depth options you go down to with your technology?
All right, so the basic, I tried not to get too techie on this one, but so I can get to 40 metres below ground or sea with high resolution data. I mean, it's conceivable we can get deeper, but we have we've limited at that because that's where we think the accuracy starts to peter out. We can get high resolution, qualitative and quantitative data down to 40 metres below the sea or the land. Normally we would tailor our equipment to around 12.5 metres below the seabed or the land, but we can go to that 40 metre level if there's a specific requirement. The cable to get to 12 metres is roughly 63 metres long, and the cable to get to 40 metres is more or less double that. So, you know, it is a bit harder to tow that 120 metre long cable, and there's a little bit more risk. It's a bit more expensive to do it, but we're certainly able to do that. And so the bins are 25 centimetres in the vertical, and usually in the order of 5 metres by 5 metres in the horizontal. So our accuracy is in the order of 25 centimetres in the vertical and sub-metre in the horizontal. Yep.
I spent a few years of my life working in the water industry, and one of the areas of frustration, relate to that as well perhaps, is that often the client would force the geotechnical risk out to all the bidders.
Yes.
And they all have to factor it in.
Yes.
Whereas if they'd gone and done their geotechnical forward, given it to all the bidders, they could get a lower price. Are you seeing a trend away from that, where the clients are actually doing some of that first?
By and large, geotechnical data is rubbish. And the government is not prepared to take risk on it. The government is finding it, in New South Wales anyway, is finding it very difficult to move or to provide confidence in, you know, newer technologies, particularly what we do. And the most common response I get to a point like that is, nobody has confidence in geophysics, and everybody only asks for more boreholes. So until the contractors are asking for your geophysics specifically, we're not going to do it. And you're like, well, you know, chicken and an egg scenario there. Which is why, you know, it's been exceedingly helpful for a couple of politicians, particularly in New South Wales, to really understand what I'm trying to do and what I have the capability to do, and then try and push that into particularly the digital realms or the digital innovation hubs within, you know, Transport for New South Wales, and getting them having the confidence of what we're doing, and then promulgating it through the remainder of the organisations underneath Transport. Yep.
So final question, sorry.
Yeah, go on.
And so how would you do in the New South Wales, the Sydney Metro tunnel system, how do you do it across a built-up area? They're going to tunnel under the, you know, 7 suburbs in Sydney, the same South West Metro system. How do you do that? Tell the tunneler what's there.
Look, you know, one of the reasons for the push into asset management is the only opportunity to get a study of the quality of some of the things you've seen is when you're in a greenfield. You simply, no technique at all is going to work through Sydney. I mean, what you saw there was underneath the harbour specifically, so obviously that's a bit easier. But so in regards to asset management, if you're going to build a big site, get this done first and get it done properly, and then put it into asset management. And then, you know, 30 years down the track, you know, you guys are talking about, you know, variation in needs. You know, you build an airport, 30 years down the track, you need to build a new shed for a new plane. You've already got the ground studies in play. And so all you're doing, you've got the base ground study there, all you're doing then is putting a couple of boreholes down to prove the data that you have in an existing format. Sorry, there's one here first.
Do you just painted it?
Look, patents, as most SMEs would know, patents are a double-edged sword. To patent someone, you've got to tell them how to do it. So aspects are patented, but certainly not all of it.
In the oil and gas industry, they do a lot of seismic survey to get the 3D models underground. How does your technology compare to that?
Currently, all geophysical techniques are lacking in the world. If you're talking about exploration, the ultra-deep stuff, are you talking for infrastructure or exploration?
For exploration in oil and gas to map underground reservoirs.
Okay, my apologies, sorry. Geophysics surrounding exploration is very, very good. But the difference is exploration is led by geologists and led by site investigators. In civil infrastructure, you know, it's a wrong crowd, but in civil infrastructure, site investigations are led by engineers who, by and large, do not understand the technology. Sorry. So yeah, the exploration they're a different kettle of fish, and they're very, very good. In fact, a lot of what I do, I've lifted from the exploration environment.
Can you expand that technology to get a higher resolution of the colour mapping, and then build a library from the jobs that you've done to do an association of the rock formations with that expanded colour library, to then increase your perception of credibility?
Look, no qualitative geophysical method in the market or being developed in the market is capable of what you're saying. Caterpillar, bless their cotton socks, built a really nice Caterpillar, earth moving equipment. But the worst thing they did for geophysics was produce the CAT table, which tries to equate seismic velocities to constructability. So, you know, if you go to the CAT tables, it's a lovely look-up table to say if you've got a seismic velocity of 2,900 metres per second, you need a D9 to dig it. That is absolute rubbish. There is no academic evidence available anywhere to suggest or encourage you taking any kind of qualitative results from one site and putting it on another site without site-specific tests. So everything we do is designed to target the borehole. So no, we will never suggest, encourage or entertain in any way the notion that you can take results from one site and push it to another site. Okay, you guys don't want to drink, do you? Thank you.
So I'd like to thank each of our speakers who presented today. I got a lot from each. In one case, the last speaker, we got the innovation on particular technology that engineers need to use in the planning phase, which we currently do not use, because the owner doesn't understand that the technology is just available or doesn't believe. And the main reason it doesn't believe it is because the non-owners, bless their cotton socks, who win the contracts to do the work, to expand the port or whatever it is to build the structure on land, once they win the tender, they know they've quoted the lowest price to win the job, and they're going to make all their money off of variations. And so do you know whose technology the non-owner goes to once they've won the tender? The non-owner contracts this company